All right, hello. We're here to go over the redox balancing homework, and we're going to just do them all because that's how bad it was.
Yes.
So, first thing, we should be assigning oxidation states, right? Figuring out who's oxidized and who's reduced. So I go through my rules, anybody by themselves. There's no group 1, no group 2. And there's no fluorine. So that means hydrogen and oxygen are their normal oxidation states. I'm trying to write the oxidation states way up here so that you know we're not going to bring those down, okay? So if I know oxygen's here, I can get carbons. And if I know hydrogen's here, I can get carbons. There it is. There it is, right? Okay. So oxidized, I'm looking for the charge to do what? Go up, which is carbons. So I pull the carbon-containing compound out of the reaction here, and the carbon-containing product out of the reaction here. Okay? Now we need to notice I don't need those charges anymore. That's important. No, I can erase, well, we'll do it. Well, why don't we write who's reduced? Who's reduced? Oxygen. So I pull out the oxygen containing reactant and the oxygen containing product. Now there's two, but I don't want to pull carbon dioxide out because then how would I get carbon on this side, right? I'd have to include the thing that got reduced or oxidized. So I don't. I pick this because I know how to balance hydrogens, right, with the hydrogen ion.
Could you just do the oxidized, everything for the oxidized and then go over to do everything for the reduced?
Yep. Okay. I just did that so that now I can erase those oxidation states so that you can see that nobody in that compound has a charge, in that reaction has a charge. Everybody's neutral. So right now, this reaction is actually balanced with respect to charge. The total charge over here is 0, the total charge over there is 0. So you could balance this like you balanced it yesterday regularly, right? Because there's no charge anyway. So you could just balance this regular way, but the idea is to practice this redox balancing stuff, okay? So now that I have my half reactions written, I go to my first one and I balance every element but hydrogen and oxygen first. So there's only one other element there and it's carbon, and there's 2 here, and so I need to get 2 over here, so I put a 2 there to balance my carbons. Right? That's why order is important. After I balance every element but H and O, then I balance O using water. So there's no O's on this side, there's OOs, and over here there are 4, right? That 2 gets distributed. So I have to put 4 waters over here on the other side. So now I have my 4 oxygens. Now I balance hydrogens using the hydrogen ion. So we got to count them. There's 8 in water plus 6 in the C2H6. So that's 14 on that side. How many H's are on this side?
0.
So I go to this side that needs the H's, and I add 14 hydrogen ions to balance my H's. See, now I have 14, right? 4 O's. All right, now charge. Last thing, charge using electrons. Nobody over here has a charge. This charge is 0. That guy is 0, and that guy is 14 things that are each plus 1. So that's a total charge of 14 plus. So I add negatives to the side with the greater charge to make it equal the side with the lower charge, which is how many? 14. Done. Okay? Did anybody get the right half reaction for oxidation?
I did.
Okay. All right. Balance everybody but hydrogen or oxygen first. There isn't anybody. What's the next rule?
H2O. Yeah.
Use water to balance oxygen. So if you want to do this, that's fine. There's 2 oxygens there, and there's 1 oxygen there. Okay? And so we need to balance our oxygen using water. So I could write another water over here, or I could just stick a 2 in front of that. Okay? I just stick a 2. Easy. It's the same. So that's 2 oxygens. Balance hydrogen using the hydrogen ion. How many do I need? 4. Balanced charge using electrons. What's the total charge over here?
0.
Nope, 0. Water's neutral, it doesn't have a charge. Oxygen's neutral, and then you got 4 things that are each plus 4. So this side has a higher charge, plus 4. That side 0, so I'm going to need to add 4 electrons to this side to get it to balance. Now the reduction reaction is done. But the electrons don't match. Well, that can't be. They have to match. The electrons that are lost by the C2H6 have to be gained by the oxygen. So there's no number I can multiply 4 by that's going to give me 14, right? So I got to think least common multiple, which is 28. If you double 14, you get 28. That means you'd have to multiply the reduction reaction. So this is going to be multiplied by 2. What's this going to be multiplied by to give me 28 electrons? 7. There we go. So now we do that multiplication and we put them back together. So I'll do my best to. So the top one's getting multiplied by 2. So 8 waters plus 2 C2H6 goes to make 4 CO2 plus 28 hydrogen ions plus 28 electrons. Okay? That was not part of the top. I was just rewriting the top reaction.
Oh.
Multiplying it by 2. Now I need to multiply this reaction by 7. 28 electrons plus 28 H pluses plus 7 oxygens goes to make 14 waters. Now I can put them back together. Now watch. The hydrogen ions, I meant to do that in the middle. The hydrogen ions and the electrons are going to cancel out. Done, right? There's 28 coming out and 28 going in. So there's a net of 0. But look at the waters. Rubinho, get off the phone. Look at the waters. You have 8 going in and 14 coming out. So there's a net. There's more coming out than going in. How many more? No? 6. 14 minus 8, right? So we just change this to 6 on the out. All right? Does that make sense? You can consolidate them. So you don't have water on both sides of the equation. Okay? You get the net.
That's what I was confused on because I have it.
Yes,
right
you
now.
have to.
Because I have it right now. I just had 28 and 8 like all written in there.
Yeah. So that's going to give us 2 C2H6 plus 7 O2 goes to make 4 CO2 plus 6 waters. Then, of course, you check and make sure you did it right. You did. I did. All right, let me pause for a moment. Questions there?
So you just subtract 14 minus 8.
Mm-hmm. It's the net. Did anybody get it right?
Without all the numbers? Without
Have exactly that. Yeah.
Oh, but I didn't go through that. I sort of just asked the thing because I did it.
But again, the idea, we already know how to balance the other way when it doesn't have charges. The idea was to practice this method, right? So here we go again. Again, the idea is to practice this method. We could probably balance this one without doing this method. It's an easy one, but the ones I'm giving you are not easy. All right, so we assign the charges. That's already got one, okay? Who's being oxidized? Mg. Valence everybody but H and O first, 1 Mg, 1 Mg. There's no H, there's no O, so then we go to charge using electrons. We need 2 over here to make it equal the other side. Any problems with that? No? Okay. Now we go to the reduced. Looks like hydrogen and HCl is being reduced. So HCl goes to make H2, right? Balance everybody but hydrogen and oxygen
I
first.
have a question.
Okay.
That the reactants, but you still only have one oxidized and one reduced.
Yes.
Okay.
There's always only one thing getting oxidized and one thing getting reduced in the equation, ever. Okay? Good question. All right, so I need to balance my chlorines. So do you see there's another product that I can put on the right that will help me balance my chlorines? The Cl minus. So you got to add that guy in to help balance out your chlorines. You're not just going to make up Cl and say there's elemental chlorine there, because there's not. But there are chloride ions produced that you can plug in there to balance your chlorine. All right, so we balanced chlorine. Next would be oxygen, but there isn't any. Next is hydrogen. How do we balance hydrogen?
We add hydrogen ions.
Hydrogen ions. Now, many of you might go, oh, well, I'll put 2 hydrogens there and then 2 chlorines. That is another way to balance it, but it's not this method. Okay? So we balance hydrogens using the hydrogen ion. Boom. Now charge using electrons. Now this is where it's confusing. This guy has a charge of +1. This guy doesn't have a charge. Okay, those charges I wrote up there, those are oxidation states. We don't include those when we're counting charges. We only include charges that are given, right? So the total charge on this side is +1. Hydrogen doesn't have a charge. This guy has a charge of -1. So I go to the side with the greater charge, and I add electrons to make it equal the side with the lower charge. What do you need to add to +1 to make it -1? -2, right? So 2 electrons. Now the charge is, right, +1 minus 2 equals -1. Now the charges are equal. So now we just put them back together. Okay, so I'll just erase, oh dear, I'll erase this. That was an H plus. The electrons cancel out, magnesium plus at that time, they were equal, so I didn't have to multiply either reaction by anything to make them equal. Anybody get that one? That was a little easier. Almost.
Yeah, I was close.
I don't know if almost counts in this. It's not horseshoe or hand grenades, right? We good there? All right. 87C. Oh, I'm hopeful for this one.
I think I got
I think we got this one. This is as easy as they get. Anybody by themselves? Okay, who's being oxidized? Nickel. See, I don't include that, but I include the charges that were given. Nickel's balanced, right? There's 1 nickel, 1 nickel. There's no oxygen, there's no hydrogen. So all I have to do is balance the charge using electrons. So what side and how many? Yeah, plus minus 2, right? Plus 2 electrons. Good. Reduced cobalt. Cobalt's balanced, 1 and 1. There's no oxygen, right? This is a lowercase o. Don't confuse that with carbonate. Okay, carbonate is capital C, capital O, 3, all with a -2 charge. This is a lowercase o, so it's an element, okay? Well, people were, so I had to clear them up. So this is cobalt, the element, it's lowercase, okay? So I just balanced charge then. 1 electron over here. If you haven't figured it out, in oxidation, electrons are being lost, so they should always be on the product side. In the reduction half reaction, they're always being gained, so they should always be on the reactant side. Okay? Now I run into that problem that I ran into in letter A, except it's easier to fix. My electrons lost don't equal my electrons gained, so in this reaction, I'm going to have to double everybody, right? I'm going to have to multiply everybody by 2. So 2, 2, 2. Put them back together. Ni plus 2CO plus 3 goes to make Ni plus 2 plus 2CO plus 2. And just to show you it's balanced, 1 nickel, 2 cobalts, let's look at charge. This guy doesn't have 1. This is 2 things that are each plus 3. So the charge over here is 6. This guy's plus 2, and this guy's 2 things that are each plus 2, plus 4 for a total of plus 6. How many people got that one? Aha. Okay, good. That's better. I'm sad to say, though, that they're not all going to be that easy. This one's already balanced. You don't have to do anything here. 1 zinc, 1 zinc. 2 hydrogens, 2 hydrogens. 1 S, 1 S, 4 O's, 4 O's. Nobody has a charge. It's done. Did anybody get that?
After you told me I did. Last night when you're like, it's already balanced. I was like,
It's already balanced. There's nothing you need to do, right? For the record, if you go through it, it's the zinc that's being oxidized and this hydrogen with that's getting reduced from the hydrogen ion. So it's already done. No sense doing that when it's already balanced.
Wait, how do you do all balanced?
There's 1 zinc, 1 zinc. There's 2 hydrogens, 2 hydrogens. There's 1 sulfur, and there's 4 oxygens, and nobody has a charge. So the total charge on this side 0, the total charge on that side 0. Everything's already equal. Okay? All right, 88. Assign the charges to things that don't have a charge because they're by themselves. Who's getting oxidized here? A yellow, aluminum. Yep. Al's already balanced. There's no O, there's no H, so we go to the electrons. We need 3 over here. 3 and 3, it gives you 0. Okay. My reduced is my chlorine, right? It's Cl2 going to make Cl minus. I like to plug in the 1 because it makes the charge more substantial to me.
Yeah.
Okay? I don't know, it makes it stick out more so you don't lose it in your paper.
Yeah.
Are our chlorines balanced?
No.
No, so we need to start there. 2. There's no H, there's no O, so now it's all about charge. Okay, this guy doesn't have a charge. This side right now is 2 things that are each -1, so that side has a -2 charge. So I'm adding electrons to the left, 2 of them, to bring it down to -2. Okay. Uh-oh, we ran into that problem again. Electrons lost don't equal the electrons gained, so least common multiple of 3 and 2 is 6. So we're going to multiply this reaction times 2 and this reaction times 3. So that's going to give me 2Al plus 3, 6 electrons. And that's going to give me 6 electrons, 3 Cl2, 6 Cl minus. All right. Now I can cancel out my electrons and plop it back together. Anybody get that one? That one wasn't bad either. Kind of easy. What else do we need there? Anything? I'm trying to go quickly, but I don't want to go too quick. So if you have a question, you need to stop me. Okay. We got 2 left. All right, we're getting up. This one's a little bit more challenging, right? Anybody by themselves? Yes. And pivot. All right. There's no group 1s, though. There's no group 2s, and there's no fluorine. So that should tell you that oxygen is its normal charge in compounds, which is -2. And hydrogen is its normal charge in compounds. And so does anybody know what lead's oxidation state is going to be in lead hydroxide? +2. Yep.
Could we have also figured that out because there's two OHs in it?
Yeah. Yep, each OH is -1. There's 2 of them to make a neutral compound. That means the lead, because there's only one of them, had to be +2. All right, questions on the charges? Who's being oxidized? PB, okay? So we gotta write the whole compound PB's in on the left, which it's not, it's by itself. The whole compound PB's in on the right. It's not like Regents chemistry where we just pull the PB out randomly, okay? It annoys me that sometimes they teach you how to do things wrong in Regents chemistry.
It kind of screws us up like that.
For later in life, yeah, it does. All right, so one lead. Go to the oxygens. So what do I need to do, Ava? To what side? Left, yep. I need 2 waters over here to balance out those 2 oxygens. Now be careful. Count your hydrogens. 4, 2. So I only need 2 hydrogen ions over here. There's only one thing with the charge in this whole reaction. Hydrogen ions. This side's +2, this side's 0. So I'm adding 2 negatives to make this side also equal 0. Both the right and left do not always have to equal 0, but they do always have to equal each other. Okay? That's important. All right, I'm done with oxidation. Reduction. Now, I do not want to include that. Because if I include this, then I'm going to have to include the lead that was already getting oxidized. You don't want the thing that's oxidized in the same reaction as the thing that's reduced. So can I get this to balance without including that product? Yeah, how do you balance oxygens? Waters, ta-da, right? You can't have the thing being oxidized in your half reaction for reduction. It won't work. All right, so I'm going to balance this using waters. Okay? And then I'm going to balance the hydrogens using the hydrogen ion.
But you wouldn't pull down PB.
Nope, because then how would you balance the lead? Oh my gosh. Okay, right? So if you brought the lead hydroxide down, then you would have to put lead over here to balance it. Lead is already the substance that's getting oxidized. That you can't do that. You can't have the substance being oxidized in your reduction half reaction. So you balance oxygen the way we always balance oxygen, using water. Okay? And then we're going to balance hydrogen using the hydrogen ion. And then charge using electrons. Casey hasn't been in school in like a month and a half. Can you stay after? No. I normally would. I'm normally here till 3:30, but we have a department meeting today, so. All right, so 2 electrons coming out, 4 electrons going in. We have to multiply that top reaction by 2. I like to do this just to remind myself what I'm multiplying it by and then just go do it. So 4, 2, 2, 4, 4. Bless you. All right, put it back together. Our H pluses and electrons are gone. And now check out the waters. 4 going in, 2 coming out. 2 where? On the left, right? The higher number. So 4 minus 2 leaves 2 up here. Okay.
I was looking for my letters.
Wait, didn't the one we did before was it happened on the right side?
We had 14 over here and 6 or 8, whatever it was, 14 and 8. So the bigger number was over here.
Oh, and that canceled out the H2
Right.
on that.
Mm-hmm. So the leftovers go with the bigger number. Anybody get it? 1? Okay.
really weirdly though. But I got the right answer. And now I know how to do it the right way.
I do think this is one you probably just could have balanced.
Well, I just did it because I didn't realize that it didn't matter that there was OH in the problem. I thought I had to bring down the PV OH, and it's like, should I just balance the entire? It was a mess, but
Yes.
I got it.
Right. All right, last one, which is the one we did.
Yeah.
Hopefully you all got it because it's the one we did in class yesterday. But again, you got to go through and assign the charges. And then getting oxidized is the iron. Balance the charge with the electron. And getting reduced is the Mn. But you got to keep the whole big thing. Now again, I'm not bringing down these oxidation states, but I am bringing down that -1 charge on this ion. Okay? And then that's going to go make Mn plus 2. So I have, yeah.
In the answer, because I got the same answer as you. If you formatted it different, do they have to be in the same order?
No.
Okay.
No. As long as what's before the arrow is before the arrow, what's after the arrow. After the arrow, order is irrelevant. Okay? So there's 1 Mn, 1 Mn. Now I go to waters or oxygens. So I put 4 waters over here because I need 4 oxygens. Then I go to hydrogen ions. There's 8 hydrogens, so I need 8 hydrogen ions over here. Now charge. So 8 things that are +1 is +8. 1 thing that's -1, so that's +7. And this guy over here is +2. Water is neutral, so this side's +2. So we need 5 electrons. So we multiply everybody here by 5. And then just put it together. Okay? Questions?
I think that one's not as bad as you thought.
Yeah, no, I definitely like those.
So I gave you 4 more when you came in. Yeah, they look like this. I have them already done. So your job is to now do these 4. We can Regents work just to make yourself feel good. It's like a confidence booster. So I might as well do it. It's it. All right. All right. That's funny. I don't know how to stop the video.
Never really had that problem yet.
Did I